Good morning. I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Software Bill of Materials. My name is Steve Warzala. I'm the CSIAC Outreach Manager. Just a few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. The briefing slides will be posted on our website within a couple of days. And finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our presenter for today's webinar, Dr. Alan Friedman. He is the Director of Cybersecurity Initiatives at the National Telecommunications and Information Administration in the U.S. Department of Commerce. Alan coordinates NTIA's multi-stakeholder processes on cybersecurity, focusing on addressing vulnerabilities in connected systems and software. Prior to joining the federal government, Dr. Friedman spent over 15 years as a noted cybersecurity and tech policy scholar at Harvard's Computer Science Department, the Brookings Institution, and George Washington University's Engineering School. He is also the co-author of the popular text, Cybersecurity and Cyber War: What Everyone Needs to Know. I will now turn the presentation over to Dr. Friedman. Good morning, Alan. The floor is now yours.
Good morning, Steve, and thank you, everyone, for joining us today. Very excited to talk to you about some work that we are coordinating at NTIA, and so we'll dive in because I think Software Bill of Materials, or SBOM, is something that, if you haven't heard of it, is something that you'll be pretty interested in and want to learn more about. So I'm going to try to leave plenty of time for questions. So first, I'm going to start with a basic motivational question, which is, how many organizations can quickly and easily answer a very simple question? Am I affected by this new vulnerability that was just discovered? We all come across this. There's a news story. It races across Twitter. It hits all the blogs where the crypto library has found to have a flaw in it, or a low-lying library has an issue. And the hard part should be in discovering these vulnerabilities. But in fact, once the security researcher, once the hacker has done that hard work, many of us have a very hard time just figuring out, hey, are any of the products I make affected? Or are any of the products that I'm running on my network that are made by all these different vendors, are any of these affected? And for me, that's kind of crazy that this takes an awful lot of time and effort. This should be a fairly straightforward approach. And so that's really what we're trying to tackle today. Now, the challenge of a webinar is I not only need to be more interesting than everything in the room, but literally the entire internet. So today, we're going to talk about the general case for transparency in the software marketplace and why we need to do this. I'm going to talk a little bit about how we get this transparency. First, acknowledging the state of play and why we don't have this today, as well as the cross-sector approach that we're taking, for those of you who want to know about the policy process. Then we're going to dive into the nuts and bolts of what is an SBOM. We're going to talk about the what, the why, and the how. And then we're going to close by how NTIA has pulled together a very broad and open community to make SBOM a reality, and what implementing this is looking like, and how you can get involved. So first, I think most of us are familiar with the idea that markets in general have some transparency, and that makes them better off. So for example, suppose you wanted a tasty and non-biodegradable treat at the store. So you go and buy yourself a Twinkie. You're not surprised that it comes with a list of ingredients because everything there does. And it turns out that Twinkies are not vegetarian. Now, that's okay because maybe you yourself don't care about that. You just want something that's going to, be delicious, sweet, and outlast nuclear war. But we all know someone who has a food sensitivity or a dietary restriction. And that's really the goal of this list of ingredients, is to put the information in the hands of those who are in the best position to make a risk-based decision based on their own profile and their own needs. And for me, it's kind of crazy that we have this for our delicious snacks in the snack aisle, but we don't have this in the most important systems that are running our critical infrastructure and that are supporting our national interest in the national defense community. And I think it's kind of strange that we don't have this, because we have transparency in other areas as well. So, for example, those of you who are familiar with the chemical industry may have heard of the material data safety sheet. You run a factory and you get a whole bunch of 50-gallon drums full of chemicals. Each of them will come with a material data safety sheet. This is an ISO standard. It's an internationally recognized standard that describes what's in a barrel and what you do if something goes wrong. This isn't giving away trade secrets. This isn't, data that has to go in the hands of every consumer, but it does have to be in the hands of people so they know how to respond to a crisis. And indeed, I keep using the term bill of materials. This comes from manufacturing, right? You can't make any device, any real thing in the world without first drawing up a list of, here are all the parts and pieces that I need to do this. This goes back to the history of manufacturing. I need to have a bill of materials so that I need to know what I am building. And today, if you buy a 10-ton diesel generator, so that you have some assurance for your community, you can survive in a blackout or a natural disaster for your organization, that will come with the list of every nut and every bolt. Not because it's a trade secret, in fact it's not, but so that you know what the total cost of ownership is and you know how to perform maintenance on that generator. However, if you buy that generator today, chances are it's going to be hooked up to the internet. And you have very little insight into whether the software stack is made up of the freshest ingredients out there, or if it's some old and rotten things that you may be concerned about. And so that's why we have this idea of a software bill of materials. And here are a couple of definitions that the community has come up with so far, which is it's a formal record with the details and supply chain relationship, or it's a nested inventory, right? It's a list of the ingredients that make up the software components and the supply chain relationships between them. Now, I'm going to talk about a bunch of different security value adds that SBOM can offer. And SBOM won't fix any one particular aspect by itself, but it is fundamental in improving the performance of a number of different things that we care about in security. And all of us have, wear different hats. What I love about SBOM is it's going to contribute to all of them. Whether you're a producer of software and you need a secure development lifecycle or a secure development process, very hard to do that without tracking your software components. Maybe you're focused on the supply chain side of things. You want to make sure that you're using quality ingredients. Well, again, hard to do that if you're not paying attention to the software. From a risk management perspective, right, if you're focusing on third-party risk assessment, you need to pay attention to what the underlying software components are. And of course, I've already talked about vulnerability management. So SBOM really contributes to a bunch of different roles and critical security functions across the entire software ecosystem. Now, let's talk about a couple examples about why we may care about this in particular. So this is a Mercedes. It's a Mercedes S-Class. From 2013. In addition to being a very nice car, is notable because the famous hacker and security expert Mudge tweeted out a couple of years ago that this Mercedes S-Class comes with libtiff, netcat, and libpcat. Now, those of you who play in the hacker world may know that libtiff is an incredibly buggy library that has lots of exploitable vulnerabilities. Netcat is a great way to move around to any network that you come across. libpcat is a great way of exfilling data. And so the joke that Mudge set us up for is that your brand new Mercedes essentially came pre-owned. Something else I want to flag for this, which is, how did Mudge know this? And the answer is, we're already disclosing some of this data yourself. So Mercedes has to disclose this data because all of these software are pieces of open source that come with explicit licenses that say, hey, if you're using this software, you need to disclose it. So we're disclosing some of it. We just don't know which versions are available. And if we knew what versions, we could say something more concrete about the relative security or insecurity of this brand new car that we're interested in. Now, I want to tell a very quick story about Shlomi. So Shlomi, we've become acquaintances over the last few months. He's a security researcher. He runs a small company in Israel. And we were both sad that we didn't get to go to Las Vegas this summer to join in the fun for Black Hat and DEF CON. Now, if I had gone, I would have given a couple talks, had a lot of great meetings, met a lot of fun old friends. But Shlomi would have given a very well-received talk because his online talk was very well received in the DEF CON safe mode. And he got to talk about 2 CVEs that his company and his colleagues found. And for those of you who aren't familiar with CVEs by rote, he is the founder, or he's the president of JSOF, an Israeli research company that found a security vulnerability called Ripple 20. Now, Ripple 20 is a set of bugs that puts potentially hundreds of millions of devices in the world at risk. And I don't want to delve too much into this particular security flaw, but the important thing to know, or the thing that I want to flag, is how did they figure out once they found this flaw? Because the flaw is in a very low-level TCP/IP library called TREC. And one of the things that any good security researcher wants to do is to notify suppliers who use those. Now, sometimes it was easy. So, for example, here's the uninterruptible power supply. Again, something that's not supposed to break. This is a smart UPS, and they had one in their lab. That's actually the picture of the one in their lab that they used to both verify the vulnerability and demonstrate the exploit. So they were able to show that they could take over this and do all sorts of malicious activity just by sending some network packets there. But they needed to find out who else was using TREC. And because no one shares this information, even with their customers, it was very, very difficult. And one of the things they had to do was they actually had to go into LinkedIn to find anyone who bragged about having expertise in the TREC IP stack, look at where they worked to see, okay, well, there's a decent chance that this, for example, very large network, very large manufacturer probably used some TREC in some of the things that they shipped. They didn't know specific products, but now they could at least reach out to it. And for me, that's kind of crazy that we're forced to using what essentially amounts to espionage techniques to figure out who is making vulnerable stuff. There has to be a better way. Moreover, when we're talking about devices, once we leave the Fortune 100, most of this stuff looks very similar. So here's some great work that comes out of NTT Labs in Japan, where they were able to build a tool to say, hey, here are all sorts of different webcams that you can buy online. And each of these looks like a different product. It's made by a different company. It's going to have a different product identifier. So if you're using a standard asset management tool on your network, you may think of each of these devices. You have, a dozen cameras on your premises. They all look like a separate device. But in fact, under the hood, they're all the same. They're all running the same firmware. And so if there's a vulnerability in one of them, there's going to be a vulnerability in all of them. It's unlikely that any of these small suppliers are going to have an entry in the National Vulnerability Database themselves. So we really need to be able to peer under the hood and find out when there's a flaw that we need to care about. Otherwise, it's going to be easier for an attacker to take over something like a camera to spy on your network. And of course, we're not just talking about consumer-grade devices. We're talking about some of the most important systems that we have. So there was a famous vulnerability discovered in the summer of 2019 called Urgent 11. It was originally thought that it was a flaw in a real-time operating system called VxWorks. But it turns out that it was actually a flaw in not just the real-time operating system, which is often hidden well below the surface level of any given product, but actually in a networking component package that was used by both VxWorks and other real-time operating systems, including some software that was made by Green Hills, the Green Hills real-time operating system, which is in turn used in things like the F-22 and some of the most important systems that we have. Not to say that any particular system is exploitable today, but it's very important that we know where things are so that we can figure out and make sure, validate that something isn't exploitable. So who should be paying attention to SBOM? Right? Who should be really caring about this? I'd argue that we're focusing first on the organizational level. And an organization cannot defend what it doesn't know about. And that's a fundamental truth. We know that's going to be the first and foremost the priority of every organization. And in fact, if we look at the Maslow's hierarchy of security, the first thing that we see in the NIST cybersecurity framework is asset management, which is to say you got to know what's on your network. And that's basic. And by the way, if anyone here is working with an organization that doesn't have the basics of asset management under control, certainly don't stop listening, but really that should be your priority, right? SBOM is going to come later. And in fact, once you know what components you have on your network, the next step is to look under the hood and say, hey, not only do I have these systems, these applications, these devices, but I need to know what the components, what they're made up of. So I'm just going to very briefly highlight the fact, I'm going to come back to this slide later, but SBOM really is not about one piece of the ecosystem. It's about addressing the software production side, the software selection side, those of you who are involved in buying things or finding open source, and of course, operating software. So this really is going to help us across the board. So hopefully by now, I've convinced you that there's some real value in thinking about SBOM and that it can make a difference. So one natural question to ask is, if this is so great, how come we're not already doing this? So first, I want to acknowledge that some folks already tried. Over 5 years ago, there was an attempt in Congress to pass a law that would have required, it would have amended the DFAR to say everything DoD buys has to come with an SBOM. Its reception was not positive, to put it mildly. The IT industry was quite unhappy, and this effort died in ignominious death, to the point where when I first launched this initiative at NTIA, I tried to avoid using the term SBOM because it had such a bad resonance and memory in certain circles. So we use the term software component transparency, because how could you be against transparency? But I think it's important to acknowledge what were some of those strong objections. First, some of them were a little bit venal. Until recently, I don't know how many of even the most sophisticated companies could honestly say that they had all their software licenses in order. Open source is widely used in modern software. Very few people should attempt to write their own software from scratch. And some of that open source software comes with licensing restrictions or requirements. And until recently, not everyone listened to them and paid attention. I'd argue that today that's a much better understood risk. General counsels understand it. There are commercial off-the-shelf tools to help you manage it. Every startup knows that they're going to have to go through an open source audit upon exit. There are even things like the Linux Foundation's Open Chain, which helps companies deal with their licensing. So it's a much better understood approach. Another challenge to acknowledge is that it's hard. If this were easy to do, folks would be doing it. And I'll walk through some of the challenges we as a community have tried to tackle and solve as we've gone through it. But one of the foundational notions is it's hard because no one is doing it. No one is asking for this data, so no one's providing it. No one's providing it, so no one's asking for it, which means we don't have a shared vision of what this data should look like and how to make it scale. Now, that's a classic chicken and egg problem. And as Steve mentioned, I have a background in both computer science and economics. And market failures are a lot of fun because they give us economists a chance to do some fun math, and that's great. But of course, they also give your friends in the federal government a chance to get involved. Now, how do we traditionally solve problems in government? Well, we have the classic carrot and stick approach. Now, fortunately or unfortunately, depending on your perspective, NTIA is not a regulator. I am not authorized by Congress to force anyone to do anything. Even less fortunately, Congress did not see fit to authorize me a giant checkbook. So I can't pay people to do things in any real amount. And so our approach has been to say, well, let's bring the community together and try to identify a shared solution. This is an area where the government doesn't have a vested interest in what the ultimate solution is. We just want a solution to exist. And so we've developed, this is your process slide, we have developed a multi-stakeholder process where we have convened a very wide range of stakeholders in an open, transparent, consensus-based process where we bring diverse stakeholders together, and we all hold hands and sing Kumbaya. And I exaggerate a little bit. I really like this approach because it's a chance to have substantive discussions that cross both the technical, the policy, and the business lines, right? We're trying to bring together the entire community. And this slide also shows the scope of what we're trying to do, because one of the key priorities is to make sure that this is a cross-sector initiative. Our key fear, and one of the reasons we're running this from the Department of Commerce, where we care about making sure that businesses can be effective, is that we didn't want sector-specific solutions that could potentially create a schism in the digital ecosystem. We didn't want a DoD land solution and a healthcare solution and a critical infrastructure solution. Right? We're all using the same underlying pieces of software. We need to make sure that the solutions are cross-compatible. So not only does it span the entire range of sectors that touch software, software, after all, is eating the world, as you guys know, but we needed to capture the entire supply chain. This isn't just an open source problem. This isn't just a commercial software problem. This isn't just an embedded devices problem, although embedded devices and OT is very relevant in this case. And we also needed to make sure that we brought the customer perspective. What's the data that you, as an organization that uses software, actually care about and can use today and may want to use tomorrow? So as you can see, we've scoped this very broadly. And because of that, we also try to make sure that this is as thin and agile a layer as possible. Folks, we're not, as I mentioned, developing new regulation. We're not trying to push for source code disclosure. This is not a formal standards development process. And perhaps most importantly, we're not trying to solve all supply chain issues and all software assurance issues and all security issues. Our goal is to make sure that this can easily dock with or map to the other solutions that you have been working so hard on, right? SBOM is something that should play well with others. We're not trying to solve every single security issue. There's tons of data in the world that we want. We're trying to focus on the basics. And we've made a lot of progress over the last 2 years that NTIA has been working on this. I think when we first started, there were folks who showed up to try to say, hey, don't do SBOM. In fact, it was quite funny. We had folks from inside the same very large company where the person from the product security team said, oh, this is a good idea. This will really help me and my team. And someone from that same company's Washington office stood up and gave a speech about why this was a terrible idea. Fortunately, the security team won, and now we're making progress with some real consensus on the broad scope of the problem, on the need to focus on a baseline. There's one mantra that the community keeps repeating is crawl, then walk, then run. There are lots of projects out there where people say, we want all the data as soon as possible right now. And I think if we're trying to make sure that something is widely adopted, we need to make sure it's easy and builds on what's already out there. We also need to make sure it's machine readable and it's scalable. And as I mentioned, that it's modular, that this can slot in and dock with whatever processes you have with the approach and the problems that you're trying to solve. There are already some documents that have been published, some great guidance on what is an SBOM, why we should do this, how we do this, and making this a priority in the real world. And currently our focus is on deployment and making sure this is in the real world. But I'm going to very briefly walk through the what, the why, and the how before we dive in. So first, Alan, you've been talking about SBOM for a while now. What actually is an SBOM? Well, here's a very simple toy example, which is in this story, we've got our Acme appliance. Acme appliance depends on exactly 2 dependencies. bingo buffer in Bob's browser. Bob's browser, in turn, we know at least includes Carol's compression engine. And that's really all this is. For those of you who are very technical or mathematically inclined, it's a directed acyclic graph that lists the software components that are used to build higher level software components. That's all. It's not that complicated. It's not that scary. With one key feature, which is we try to make explicit unknowns known to anyone who touches this data. So again, in our toy example, we know that Carol's compression engine is a root of our tree, or a leaf, depending on how you like to talk about your trees, in which case it has no further dependencies. That's known. Similarly, we know that Acme Appliance has exactly 2 dependencies. In this example, we have no idea if Bingo Buffer has any further dependencies. It may have no dependencies, or it may be the top of a very large, dark tree. What I like about this approach is we're not demanding a single solution. Rather, by making the unknowns known, now anyone who's doing some basic risk analysis can look at this and say, well, is this enough information? Do I need to ask more questions of my supplier? Do I need to use a source composition analysis tool? Do I need to go to a risk analysis tool? Things like that. Really is about, going back to the list of ingredients, empowering folks to take the decisions that are right for their level of risk. Now, for each of these components, we don't need that much information. Now, we may want a whole lot of information. When I go out and talk to our colleagues in the IC, they sort of said, well, we want all the information about every single component, about everyone who's ever touched this piece of open source software, et cetera, et cetera. And that's a great goal to have aspirationally, but I think we're unlikely to get it in the short run, especially from the commercial and COTS world. What I think is acceptable to ask for from the open source world and from the COTS world is this basic set of information of, hey, who's the supplier of this? Did it come from a package manager? Did it come from a corporation? What's the component name? What's the version, right? Is this the up-to-date version or is this an out-of-date version? Is it vulnerable? And what's the hash to make sure that you and I are talking about the same piece of software? And so that you feel confident knowing that I didn't accidentally use a backdoored version that one of my engineers downloaded from GitHub without realizing that I was introducing a vulnerability. So again, we can have that. That's not that much information. How many levels deep do we want to go in the tree? I've talked to folks who say, I want to know everything that's in this mechanism all the way down to where did the sand come from that was used in the silicon. And again, if you can use that information, great. If you can get your supplier to give you that information in a machine-readable, digestible, semantically resonant fashion, that's wonderful. Right now, we're focused on saying, how do we get as much information about the software as possible? The community was explicit in their lack of their interest in saying we're not going to be overly prescriptive. So the minimum amount of information is all of your top-level includes. So if you make a piece of software, what are the direct includes in your software? Now you should ask for those includes. And ideally, we'll be able to recurse our way up the supply chain. And especially as we hit open source, it becomes easier for anyone who cares about this information and doesn't have it to do a little basic research and find that information. So that's the basics of what this is. It's a tree that we're all going to learn how to fill in as we go. Now, I've already talked a little bit about why we should SBOM, but I want to reiterate a couple of things. First of all, again, the value changes depending on where you sit in the supply chain, but it provides real value today. One story I love to tell is that Bank of America already been asking for an SBOM for several years. Not the entire bank, but a chunk of it that's under the management of a security expert named Sunil Yu. And he asks for an SBOM not because he thinks that the data is easy to use today, because he was asking for an SBOM before we really talked about the standards that I'm going to mention in a little bit. He asked for an SBOM because he knew that if you couldn't give an SBOM, your software development process was going to be flawed enough that his team's total cost of ownership was going to go up. And so he was going to ask for a 5 to 10% discount off your asking price off the top. This isn't just about security. This is about real dollars and cents, both for operators and for software vendors. The other thing I want to flag is this last point under operate software. which is if you know what's in your component, you have options for other independent mitigations. So here's a fun case study on remediating a supply chain vulnerability with and without an SBOM. So on the top, we discover a vulnerability in January, and then we have to spend some time making a patch. And that's okay, right? SBOM won't solve everything. It won't make it faster to build a patch. But what it will do is it will help everyone realize that there's a potential vulnerability at time T0. So rather than waiting for this waterfall model to percolate down, for the patch to come all the way downstream to you as the final customer, when we all know about this potential vulnerability on day one, we can take other remediations. So we can tune an intrusion detection system. We can segment a network. We can talk to our threat intelligence team and say, hey, I'm leaving this potentially vulnerable system online, but the second you hear any hint of an exploit in the wild, let me know, and I will yank it off the network. So it's about empowering people to make these great risk-based decisions that we know we need to make. This is about empowering those decisions. Another approach is that this can actually bring some Darwin into the 21st century, of really allowing us to sort of look upstream and rewarding suppliers for making good decisions and rewarding open source projects for having good security and good organizational practices. Right now, it's very difficult to know if the system that you're using depends on a system that depends on a component that depends on a component that really has only one developer out there, or is using good practices for their development keys or for other security approaches. So by having this transparency, it's going to allow those of us who really care about good security and good software to apply a little pressure and make the whole ecosystem better off. So we've got the what, we've got the why, but how do we do this? Remember, it's got to be machine readable to work. As I mentioned, we did not want to have this be a standards development process. There are already a number of standards out there, and we were confident that at least one community would come forward. And that's the good news, is that at least one community came forward and said, we have a data format that we think can convey SBOM data. The bad news was that more than one community came forward and said, we have a data format that can be used to implement SBOM. And in fact, there are 3 out there in the world today that are already being used or that have been extensively talked about. SPDX comes out of Linux Foundation, extensively used in the open source world, and has a large community that's interested in it. It was originally meant to think about software licensing, and so it's something that already has buy-in from a lot of lawyers and boardrooms as well. SWID tags also comes out of the licensing world, but from the commercial space. And it has the benefit of being an ISO standard. It doesn't have nearly as large an active development community that we've been able to find, but there are some folks at NIST that are very interested in using this, and I'm happy to chat a little more about that. And there's a third standard here called Cyclone DX that is quite new. In fact, when I first started this initiative, there was really only one developer, but it's since developed a very active community and has been starting to be used in a lot more projects. It's very popular in the application development world. And so those of you who are in that space may want to check it out. It comes out of the OWASP community. So our vision wasn't that government should pick a winner. It's not our job. Rather, we wanted to adopt a strategy of radical ecumenicism, where we were going to identify the common elements and make sure that there could be interoperability between them. So ideally, you could get SBOM data in any of these 3 formats and still put it into the systems that you cared about. Or if you were a producer, your customer could ask for any format, and it would just be a keystroke to give them the format that they were interested in. So we really believe that we can have a multilingual ecosystem. The analogy I like to use is Canada, where in different parts of the country, we're going to be speaking different formats, but we're going to make sure that largely we have maximum interoperability. And in fact, here's a great example. These are these core fields that I talked about. And here you can see how to implement them in SPDX, SWID, and Cyclone DX. The other detail here that I want to flag for you is that we also include the SBOM author. who supplied the data that you're reading, because it may come from the immediate supplier, it may come from someone further upstream, it may come from a source composition analysis vendor. There are lots of sources here that we may care about. So that's very briefly the how to do this. What are we actually doing to make this a reality? Because it's one thing to write some government papers. Who doesn't love reading government white papers, even when they are written by the security experts in the community rather than the government itself? One of the great things that's happening is, let's see if that slide pops. There we go. The healthcare proof of concept work. So the healthcare community, we don't usually think of as leading the charge in cybersecurity. In fact, usually they're a bit of a lagging sector. But in this case, they've played a huge leadership role. They knew this was something they needed, especially for medical devices, which are quite opaque to a hospital security team, right? It's the blinking box that's keeping grandma alive, but who knows what's underneath the hood. And so over the course of 2019, a handful of large medical device manufacturers in the US and around the world partnered with some of the leading hospitals in the United States to generate SBOM data and send it to the hospitals. And the hospitals worked to integrate this data into their defensive systems, into their blue team systems, including asset management, risk management, and pre-purchase risk analysis. Now, this first exercise was great. Folks were able to show that it was possible. But because it was happening simultaneous to all the other work that I just described, no one was able to do it in a completely automated fashion. So in 2020, they started a second proof of concept exercise, which is really fantastic. I'm blown away by this because, of course, the healthcare sector has been a little busy in 2020. But this has remained a huge key priority. And we have literally the security teams from the best hospitals in America, Cedars-Sinai, Mayo Clinic, Cleveland Clinic, Harvard, Hopkins, New York Presbyterian, have been actively participating throughout the entire COVID crisis and devoting time and effort to this. That's how important this is. And they're able to sort of tackle this and show that SBOM data not only is possible to generate if you're even a legacy manufacturer like a medical device manufacturer, but it's something that can be integrated into our security teams. That's work that's happening, and in fact, it's continuing into other security, other fields as well that I'll talk about in a moment. So the next steps for the community that's been going on over the last 6 months is to extend the model and make sure that we've fully mapped out all of the architectural hurdles, and I'll talk about just a few of those. Focusing on tooling. So now that we have the 3 standards identified, we're helping to find the key tools that exist today. So the community has built a taxonomy of different types of SBOM tools that are helpful for generating and consuming SBOM. And they're starting to list, here are the open source tools that can do this today. Here are the commercial tools that can do this today. So if you're a tool vendor, this is something to think about. We'd love to put you on this list. It's public, and it's something the community started to rally around. It's also helping us think about what are the gaps. So if you're someone who's thinking about how you might be able to better serve your customer, we're starting to analyze what gaps exist. Finally, we're emphasizing awareness and adoption. How do we get this message out into the community? One key way is things like an FAQ and some 2-pagers, but also draft contract language. This is meant to be a market-driven approach, and so our vision is how do we make it easy and cheap for suppliers to offer this in a uniform way, and for customers to ask for it so that they aren't getting it in a million different ways. And the last thing we're emphasizing here is playbooks. And in fact, in our October 22nd meeting, we're going to be releasing the first community drafted playbook on how to generate SBOMs, which lists the steps that folks need to go through. Here are the decision trees that you need to walk through. So there are a couple challenges we're walking through. A piece of software by any other name may smell as sweet as a rose, but it's unlikely to be easily mapped to a vulnerability database. So for example, is your project built on com.sun.java or com.oracle.java? Now, of course, it's the same thing, but really, if you're trying to map it to a vulnerability database, you need the concrete string. The good news is there's already a couple of naming formats out there. The bad news is there are multiple naming formats out there, And so we're not going to instantly solve this problem, but we are providing some guidance to help the community into a path of convergence and automation. Sharing SBOM data is also critical. There isn't going to be a single one-size-fits-all approach. And so our vision here is to map this into other initiatives. Some of them already exist, like the manufacturer usage descriptor technique that's been built by the IETF, or OpenC2, or other approaches. And there's some evolving, there's some new efforts that are coming out of the community, such as the DBOM effort that Unisys is pushing, that can be used to share this. And really our vision isn't to say, here's the single way to do it, but to help more organizations understand what the range of options are and provide a limited set of options so that folks can pick what works best for them. The other thing I want to flag for you is to acknowledge that not all vulnerabilities actually put us at risk. So let's use everyone's favorite example of Heartbleed. Right? Depending on how you measure it, OpenSSL 0.9 has between 600 and 1,000 different function calls you can make. 2 of them call the code with the famous Heartbleed vulnerability. So if you're using OpenSSL 0.9 and you're only using, say, the pseudo-random number generator, you're not putting anyone at risk. There are lots of ways that you can mitigate a vulnerability that nominally exists. We want to make sure as more and more people use SBOM data, we're not creating false positives. And so we're creating, the community is working on creating a way of communicating downstream the lack of exploitability in a software product. Now, of course, there are lots of policy implications and business implications as well, but we want to define the basic technical and operational concerns there. And I'm happy to chat more about that if folks are curious. But the one thing I'd love to try to convince you of is that the time is now ripe for your organization and your community to think about demonstrating this. There's a lot of support from the community. There are a lot of people who would love to help you think through this, including a lot of experts from the healthcare sector, which bring a lot of experience and hard-fought lessons. There's documentation that's going to be available on the NTI website. And so I know it looks like a scary thing to dive into, but this really is going to be the next step for supply chain risk management and for software assurance. And so now's the time to think about doing a proof of concept exercise, if for no other reason to think about what will work for you and what the community needs to include to meet your needs, right? Our vision here is to say we should have a shared vision of SBOM, but we want to make sure that we can accommodate everyone's special concerns depending on their own unique situation. So how can you get involved today? Well, first and the easiest thing is start asking for SBOMs. Ideally, ask how your organization can provide an SBOM, or just how to think if you're focused on a different area of security and software assurance or supply chain or risk management. Think about how SBOMs can supplement the work that you're already doing. And then lastly, the plea is to join the SBOM community. We have well over 100 folks that have been engaging in different capacities, whether it's just listening to quarterly meetings, reading draft documents and offering feedback on them, joining working groups. There are 4 active working groups, and you don't even have to join weekly calls. You can just join the mailing list and listen in and make sure they're not doing anything stupid. And if you'd like a briefing for your organization that offers a little more detail and a chance to engage further, rather than just listening to this webinar, I'm more than happy to schedule a briefing for you and your team. So summing up, transparency is part of this nutritious breakfast. And it's not going to be the be all and end all, but it's going to help us make this breakfast even more tasty and more delicious. So recapping here, we've done some great work establishing the what, the why, and the how of SBOM, but ongoing work is going to need your help to build and use this SBOM data. Here's how to get in touch with me. There are lots of folks talking about this on Twitter, if that's your particular mode. People are writing LinkedIn articles. So keep an eye out for SBOM, and be happy to talk through some of your questions and concerns now, or to hear why we're completely wrong.
Thanks, Alan. That was a very interesting presentation and very important topic. Before we jump into the Q&A, I want to piggyback off of some of the information you talked about, in particular the healthcare, the proof of concept you talked about. So I just want to mention that we're in the midst of National Cybersecurity Awareness Month here in October. And CSIAC is participating in that event. And so next week, we're going to have another webinar coming up on Tuesday, the 20th. It's going to start at 1 p.m. And that's going to be an update on current cybersecurity efforts. That's going to be a presentation by folks from the FDA. And so that's going to be talking about medical devices and examining cybersecurity for the healthcare sector in general. So I just wanted to let folks know about that before we start running some questions by Alan here.
And there are a few better experts than Jessica. I'm a big fan of hers.
Okay, great. Thank you. Thank you very much. So one of the questions that we've got, let's see, it says that it seems if improperly done, when the information is shared, like a health information exchange, people will be able to find a targeted list of companies that they are able to exploit. So, is an SBOM going to be public? And so what would prevent folks from exploiting this, taking, using this for negative purposes?
That's a great question, and one that we hear fairly frequently. So I'll talk about the fact that they don't have to be public in the future in just a moment. But first, let's just roll with this and say, let's assume that it is public. Are we creating a roadmap for these attackers? And first, to answer this question, I think we would talk about, say, it's 2020, so we don't just talk about hackers as a giant amorphous group. We threat model. So let's do very basics, and we'll divide our attackers into three groups. We've got the sophisticated, the moderately sophisticated, and the unsophisticated. But the sophisticated folks, they don't need this, right? Reverse engineering is pretty easy. Jira is open source. Anyone who wants to know what's in the software of an organization they're targeting can figure this out without too much difficulty. So your sophisticated actors don't need this information. Your unsophisticated actors, right? The folks that are doing, just bulk ransomware or spray and pray script kiddies, they're not going to be bothered with this, right? They're just using automated malware. And for that, the asymmetry is on the defenders. The defenders have no idea if any of the software on their network is potentially vulnerable. So really here, the idea is giving a roadmap to the defenders to help them figure out what they need to defend. Now, I'm willing to acknowledge that there may be a middle set of attackers that we need to be focused on where this could fundamentally change the economics. But I think the value of putting this in defenders' hands outweighs that, especially when we acknowledge that this data doesn't have to be public. There are a bunch of different ways that we can think about how this data can be distributed downstream. One of them is just saying, listen, if we're using traditional on-prem software, you just put the SBOM next to the software. So, right, if it's sitting on Platter, the attacker is on Platter, you've got other problems. And similarly, in the embedded world, we're working closely with some folks in the IETF who are big fans of this protocol called MUD, which is a model to allow devices to share security information about themselves. And so essentially, we're allowing the network device to share the location of its own SBOM rather than having everything be completely public. And there's going to be a document shared on October 22nd that offers the range of this. One of the things I like that the community has done is they've drawn a separation between how do you advertise the location and the existence of an SBOM and SBOM data and the access control that you use to figure out who can gather it. We didn't want to create a brand new standard, and so there are other areas that access control exists. So for example, access to software update information, access to support data. Many large vendors already have controlled access and don't want to make this stuff public to start with, so let's not reinvent the wheel.
That's awesome. Thank you very much. That's a great answer. So we have one of our attendees has a question, and he's wondering if Are you aware of any DoD organizations that have implemented SBOM as a contract deliverable? Have you heard of anything like that?
We've had a number of conversations with folks across DoD, including with Dana DC and his team over the last 2 years. To my knowledge, while there are things that look SBOM-ish as part of contract requirements, to my knowledge, they don't follow this basic model. But I know that this is something that is of increasing interest in many different parts of DoD and the services and some of the research labs that support the services. So we think this is coming. This is the sort of thing that we've tried to encourage folks to say, let's make sure it works before we start writing it into bulk policy.
Okay, kind of like the doing the old proof of concept for the SBOM before we make it a requirement.
Exactly.
Smart move. Okay. So another attendee is wondering if there are any formal SBOM standard efforts in the works other than the ISO SWID tag one that you mentioned.
There are. The questioner is, in fact, actively involved in leading one of them through the object management group, trying to build a formal standard. And of course, and that's going to be some fun work to watch. So you should check out the OMG effort. And of course, SPDX through the Linux Foundation has lots of relationships into the standard world as well. OWASP has ties to the standards world. So right, depending on how formal a standard you need, there are some great solutions out there. The most formal is the work that OMG is just starting, or rather is developing as a sort of very rigorous formal standard.
Okay, thank you. So another attendee has the following concern. So she says that the small team of developers is worried about how much work this is going to be for them to track all the included libraries and versions. So how does automation work for this? Could that help improve that process?
No, that's a great question. And in fact, I'd put it to you that when I talk to organizations, this is actually often a much heavier lift for large legacy organizations than smaller, more nimble software development shops. Because if you are small and have a decent development process where you can document what you're using, then a lot of this information is available. And especially as we start to make headway into the open source community, and what I like about our partnership with folks like Oasis and the Linux Foundation and the Apache Foundation is this is something that they're really excited about as well, because it's going to restore confidence or help support confidence in the open source world in high assurance communities, is that I think this will be a little easier to integrate, right? One way of thinking about this is, and I'm going to date myself for a second, this is really just a couple of extra lines in a make file, right? It's very hard to compile software without the compiler actually identifying what the pieces that are being pulled in and what their subsequent upstream dependencies are. That's the act of building software. And so as we make progress on this, there are more and more tools today that are integrating this. So for example, CycloneDX, if you're in the application development world, can point to a whole bunch of tools where this is being implemented into today. Source composition analysis tools that folks are using, such as Veracode and SNCC and Synopsys, are already developing products that can produce SBOMs in one of these data formats that I've talked about today. So there are solutions today that require a little extra work, and we believe that as we move forward and make progress, it's going to be more and more turnkey, and it's going to be a trade-off of, like anything else in security, there'll be open source options that you'll have to put a little more effort into, and there'll be commercial options that will be easier to use, but of course have a slight cost to them, just like any other part of security.
Awesome. Thank you. Thank you for answering that. So another individual's got a question. He's curious about the differences between SBOM and software VDD, and if you have any perspective, on the views between those two.
Well, let me see how quickly I can Google software VDD, because that is.
Okay. I wasn't the only one. Thank you.
So I'm happy to hear more about VDD, but I can tell you that having, and this could explain, I could be exposing the circles that I run in. But having talked about software dependencies now for many, many years, I must confess ignorance of VDD, which could be the version description document. Yeah, happy to learn. I'll learn more about that. Feel free to send me an email if you want to brief me, and we can have this conversation. Because I'd love, if this is something that you've worked on, I'd love to know more about it and make sure that it's integrated into what we're thinking about.
Okay, great. So David, if you want to follow up.
Vendor due diligence was the other option that it could be. And and again, we've got a lot of interest in the third-party risk management world. Right, again, so the power of SBOM really is carrying information down the supply chain. And so this is a natural fit for those of you who help other organizations think about, is this risky? How do we mitigate these risks? And I think SBOM is going to play a large role in that. I've briefed a number of third-party risk organizations on this topic, and I know this is something they're starting to look at in great detail.
Okay, thank you. So there was a question about do language barriers create obstacles to the idea of an SBOM, and then do language barriers inhibit finding vulnerabilities? Any thoughts on that?
So if we're talking about the differences between programming languages, I think the gaps between the different worlds is really just the chunks of the ecosystem. So there are some areas, if you're an NPM app developer, web app developer, you live in a very different world than how someone who's building supporting a communication system for a weapon system, right? Where there's a lot of legacy code that you have to handle, and a lot of freestanding pieces of software. And that's really where we're finding the differences in implementation, because you're going to have a different set of tools, a different set of programming paradigms. There isn't going to be a one-size-fits-all approach. And that's where we're trying to help different parts of the community understand this. So, right, the web app community is moving in one direction with DevSecOps tools and things like that, and that's wonderful. But we also want to make sure that we're accommodating folks that are thinking about embedded systems and legacy systems as well. And that's one of the reasons I've really emphasized the importance of making sure this isn't just about the latest and greatest of security tools, that we have to actually reflect how software is built in the real world, especially in embedded, and frankly, those of us who work in the software for government and national security, alas, aren't always at the vanguard of development.
Okay, thank you. Yeah, right now, this is our last question, and we're right on time, so this is working out perfectly. So there was an interest in your community draft playbook, and folks are wondering if that'll be publicly available, or if there's some way, if they'll need to explicitly request access to it, and when that might be available.
Sure. Thank you so much, and I want to thank Steve and John and and Deborah, the CSIAC team, for arranging this. This is a lot of fun to chat with you, and this is some of the best audience questions I've received in a while. So thank you. The goal of this process is to be as transparent and open as possible. Full documents that are seen as finished go on the website ntia.gov/SBOM. If you'd like to receive draft documents and the slides from the working groups as they present at the quarterly approach, it's at a website called ntia.gov/software transparency. Or the easiest thing to do is just send me an email. I'll add you to a very light traffic mailing list, And that way, whenever there's a new draft document or a new event that we're announcing, which is, again, once a month, twice a month at most, you'll get some information about it and you can engage. And I'm also happy, as I mentioned, to brief anyone who wants a little more detail for their organization.
That's fantastic. So, Alan, I want to thank you for taking the time to share your knowledge and experience, share this information with our audience today, and thank the attendees for joining us as well. And once again, just remind everybody that we'll be back next Tuesday with Jessica Wilkerson on talking about cybersecurity for medical devices, healthcare area, and we hope you have the opportunity to come back and join us for that as well. So with that, I'd like to wish everybody a good day, and we'll see you in the near future. Thank you. Bye-bye now.